Assalamu alaikum all of you. So here we are with the first topic for GCSE and IGCSE, that is data representation. Now first of all we need to understand that what is a data representation. So data representation is something that whenever we are going to represent any sort of the data in our system. Now what is a system? Now you need to understand what the system is something, anything with a microprocessor, anything with a microprocessor. So anything with a microprocessor is basically is known as a system. So whenever we are going to represent any sort of the data, whether it's a graphical data, whether it's a vector graphic data, whether it's a numeric data, or any other data, or sound data, or MP4 data, the video data. So if you're going to represent any sort of the data in a system, so that is known as data representation. Now for this data representation, first of all we will be dealing with the types of the number systems. Now why are we dealing with the number systems? Actually we are dealing with the number system because we need to understand that how do we represent any sort of the numeric data in our system. So when it comes towards the number system, so if you can see on the screen, it's written over here that way or procedure or a method of representing any sort of the numeric data in your system is known as the number system. Now, when it comes to the types of the number system, so in actual, we do have four different types of number system. What are those? We do have a binary, we do have a hexa, we do have a decimal or a denary, and the last one is known as the octal. But out of these, binary is the part of your course outline, hexa is the part of your course outline, denary or decimal is the part of your course outline, but when it comes to the octal, so it's not the part of your course outline, so we won't be dealing with the octal number system. Now when it comes to the binary, so binary number system is actually a sort of a number system that is understood by a system or by a computer because it is dealing with the ones and zeros. Okay, before going ahead, we know that computer is an electronic device. Now electronic means that the device or any such sort of the thing is working on created voltages, so we do call a system an electronic device because it is working on those created voltages. And do remember that in the voltages we do have only a 1 and a 0, that means on or off, on or off. So computer is actually understanding the language of the voltages, that is ones and zeros, that is an on or off. So over here we are saying that the binary number system is actually the type of the number system that is understood by the systems. It do have a base 2. That means if I need to represent a number, like for example I'm writing a number over here 100101. Now how do we know? We can just count it as our normal number system as well. Okay, that means a denary or a decimal number system. But how do we know that it is a binary? So to recognize that it is a binary, we do write a 2 in the base that represents that it is a binary number over here. So range over here, that means the binary number cannot have any number less than 0 and it cannot have any number greater than 1. Minimum number of the bits, binary will be dealing minimum with the 2 bits and maximum it can go to any number of the bits. There is no limit for that. Number of the combinations. Now for the number of the combinations, I do write a formula that is 2 power, sorry, it is 2 power n. I mistakenly wrote 2 power 2. It is 2 power n over here. Yeah, so it's 2 power n, where n is the number of the bits. Now how many bits it was utilizing? It was utilizing 2 bits over here. So we do say 2 power 2 will be equal to 4. That means binary can go with the 4 combinations. Now what are those 4 combinations? We will be dealing with them and we will be coming towards the conversion table right at the bottom over here. Coming towards the hexa. Now what is a hexa? Hexa is something that is a sort of a midway language or a midway number system between a human and a machine. It is utilizing 4 bits at the time. As I told you, for the binary it is only utilizing 2 bits at a time. or you may say minimum of the 2 bits, and maximum can be any number of the bits. But when it comes to the hexa, so it is utilizing only 4 bits. At max it can only utilize 4. Similarly, at minimum it can only utilize the 4 bits. Now when it comes to the range, sorry, first of all, when it comes to the base, so how are we going to recognize that it is a base 16 number or it's a hexa number? So similarly, if I'm writing up a number over here, for an example 1001, and now I'm writing a base 16, so now it is a hexa number. Now it's not a binary number because the base is 16 over here. Now when it comes to the range, so for the range, it may have the minimum of the 0, not less than that, and it may have a maximum of 15, not more than that. Okay, just after the 15, I do have wrote that /f. Now what do I mean by that f? So this is one more thing that I'm not going to explain you right now. I will be explaining you when I will be dealing with the conversion table. So two things till now I haven't explained you guys. That is with the number of the combinations. What do I mean by the number of the combinations? Similarly, why f is written with the 50. Similarly, number of the bits, as I just told you that hexa will be working on the 4 bits. Number of the combinations, 16 are over there. Coming towards the denary. Now when it comes to the denary, so denary is a number system that is utilized by the humans. So base over here is 10. For example, now again I am writing a number 1000. Now base 10 means that it's a number system, or you may say that is utilized by the humans. So it's 1000 right now. So base is 10, range is 0 till 9. That means neither a number less than 0 and neither a number greater than 9 can be in this range. Okay, now as we know that when it comes to the denary number, so any number that is created, it can be further explained by the mathematics teacher as well, that any number that is created in the mathematics, as much as big number you are going to create, no issues with that, but that number will actually be the combination of these 9 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So only, sorry, not 9 digits, actually the 10 digits starting from 0 till 9. So any number that is created, how long you are going to create it, no issues with that, but that number will be the combination of these 10 digits over here, nothing apart from that. So these are the 10 numbers that we are these are the 10 digits that are going to make up the combinations. Okay, coming towards the power of the 2, so you don't need to memorize these power of the 2's. Starting from 2 power 0 it's 1, and then till 2 power 11 it's 2048. Okay, for your GCSE and IGCSE you won't be getting any number more than 2 power 11. Why so? Because your course outline suggests, or your core outline, we do have a clear instructions that maximum of a 12-bit number. So how many numbers will be, or how many powers will be there? So starting from the 0 till 2 power 11 it will be overall 12 bits. So maximum of 12-bit number can be done, not more than that. By chance, god forbids, if you are getting that thing, so what you need to do, you just need to multiply 2048 by 2 once again, and you will be getting the next number. That's quite simple. Now coming towards the conversion table. Now what do I mean by the conversion table? Now conversion table, what I've written over here, first of all you guys need to understand that thing. So for the decimal of the denary number, it's from 0 till 15. Now starting from 10 I wrote /a, then b, c, d, e and f. Just after that I do have written binary. So in this conversion table, what I've done, I've actually represented a 0 into decimal place, on 2 bits. Then in octal I do have represented it in 3 bits, and in hexa I have represented in 4 bits. Now the question may arise, sir, why are we studying octal although it's not the part of the course? It's not the part of the course outline, but it will be giving you an help when you will be doing with your logic gates or the Boolean logics topic. So at that moment it will be giving you a bit of the help. So that is the only thing. Okay, moving ahead further. First of all, I need you to understand the concept of the bits. So we do have a definition of the bit written over here. Yeah. So what is a bit? Bit is something, for example, we do say in chemistry or in physics, we do say the smallest element of any of the matter. So we do say the smallest particle of, not an element, sorry, the smallest particle of any of the element or any of the matter is atom, ATOM. So similarly, when it comes to the computer systems, so computer system, the smallest unit that can be processed, or the smallest memory stuff that can be processed by your microprocessor, is known as the bit. So I mentioned over here, the smallest unit of the memory that can be processed by a system is actually known as the bit. Coming back to our topic, to the main thing. Now we do say what I have done over here. So now let's consider this thing. So for this thing, what I am doing, let's consider I do have two bits right now, 1 and 2. Now each of the bit will be given a power, 2 power 0, 2 power 1. Now for 2 power 0, we do have a 1, and for 2 power 1, we do have a 2. As I just told you guys, that we do have two things, 1 and 0. 1 stands for on, whereas 0 stands for off. Now I do say, let's consider right now, right at the moment, both of the bits are on. Now if both of the bits are on, so that means both of the bits are considerable. So what I'm gonna do to convert this thing into the decimal format, that means in a human understandable format, if the bits are considerable, if the bits are on, so I will be adding the answers of the power, that means 2 over here and a 1. I will be adding both of them together and I will be getting the result 3 in my, or in a human understandable language, or in my language. So I hope this point is clear to you. Similarly, if I do say, okay, now what I'm doing, I'm putting up a 0 over here at this place. Now my one bit is on and the other one is off right at the moment. That means your left side bit is on and your right side bit is off. So which one is considerable? Only the left bit is considerable. Why the left bit is considerable? Because only this one is on, so only this one is considerable. So the bit that is considerable, I am only going to add that particular bit. So I will be removing the 1 from here because that's not considerable right at the moment. So I will be getting a 0 over here, and now if I'm adding 2 with a 0, so the answer that I will be getting will be a 2. Now if you can see, just in front of 2 it's 1 0 that we just got, and in front of 3 it's a 1 1 that we just that we got earlier. 1 0 for the 2, for 3 it's a 1 1. Now coming towards the next part, now let's consider that I have switched off both of the bits. So obviously none of them is considerable. So if none of them is considerable, so obviously I will be getting answer 0 over here. So if you can see, just in front of 0 on the 2 bits, it's written 0 0. Now we came to know that the minimum number 0 can be created over here, the maximum 3 can be created. But what if I need to create up a 4? So I cannot create up a 4 over here on 2 bits. What I need to do now, I actually need to increase the bit. Now I will be increasing the bit. So once I'm going to increase the bit, it will be giving me a 2 power 2, and the answer for 2 power 2 is 4. Now the maximum number that I can get over the 3 bits will be, if I'm going to get them all on, that means all 3 of them are considerable. Now if I can see over here, so 4 will be on, 2 will be on, 1 will be on. That means I will be getting answer 7 at the moment. So if you can see that on the 3 bits, maximum number is 7 and the minimum number is 0 over here. Coming towards the hexa, that means if I need to create up a 8, so 8 is something, okay, I just forgot to tell you one thing. For the binary, I just told you guys that 0 till 3 can be created. So over here, I just wrote number of the combinations 4. That means I am getting the 4 combinations. For octa, okay, we haven't done with the combinations over there. Now coming towards the hexa. So hexa is something we do have 4 bits. Now, so we will be considering the 4th bit as well. Now, if we are on the 4th bit, the value for 2 over here will be 3. That means it's a 8. Now just consider that all 4 of them are on right at the moment. So we will be having 8 plus 4 plus 2 plus 1, and the answer that we will be getting is 15 over here. So if you can just see in front of 15 or in the similar row for the 15, we are having a 1 1 1 at the moment. Okay, so this is how these conversion tables are created. Okay, now one more thing. If I'm gonna write it down, 1 0 2 9, base 16 number. It's a base 16 number. I'm first of all telling you that. Okay, now let's see that whether it's written 10, 2 and 9, or it is written 1 0 2 9. Now it will be giving you a, you may say, it will be giving you a mass or something like that. Like you will be in a confusion that whether it's 10 to 9, whether it's 1 0 to 9. So just to avoid this confusion or to avoid this mass, what we say, for the hexa, after 9, if I need to write up a 10, so I will be utilizing a for that particular, sorry, I will be utilizing a for that stuff, so that it could be easy for me to recognize that it's not 1 0, it's a 10 over here. Similarly, for 11 it will be a B, for 12 it will be a C, 13 D, 14 E and 15 F. So this is how we are going to understand this part. So this was all for the session. In the next session we will be understanding that how we are going to convert from one number system to another number system. Thank you so much, guys.